moving on to more key features of our quadratic function. Now, just to recap, we went over the domain. That's all x values. We went over the range, all y values. The vertex is kind of the originating point. And then in parentheses, I'm going to write it's either going to be a maximum or a minimum. Okay, now these are really, really loose definitions. They're actually really not definitions at all. It's just kind of how I think about things. So as we go through this, if you don't like what we wrote here, go back and change it to something you're going to understand. Okay, now originating point, it's either a max or a min. On our next example, when we actually label the vertex and label the axis of symmetry and label some of these things, this is going to make more sense. So the next one is our axis of symmetry, and it's the axis that cuts parabola in half. And again, there's definitely a better definition for that. This is just kind of what I'm going with. Increasing where graph goes up. Okay, increasing, we're kind of going up. Decreasing where graph goes down. Positive, where graph is above the x-axis. And then last but not least is negative, which is where graph is below the x-axis. Now again, as we go through these on the next example, if you don't like any of these definitions, that's fine. Just go back and change them. So let's go see what we've got here. So number one, identify the key features of each function. And of course we have domain, range, vertex. This AOS stands for axis of symmetry. It's just shorthand, increasing, decreasing, positive, and negative. So we can write this in inequality notation. We can write this in interval notation. I'm going to switch back and forth so we kind of get used to both. On this first example, I'll probably do both notations, but then after that, I'm just going to switch over to one. You can do whichever notation you feel most comfortable with. Now, starting out with domain, that's all the x values of our graph. So, x values, oh dear, let me fix my highlighter here real quick. Actually, maybe I could do this. There we go. Okay, there we go, I got it. So, domain, x values, highlighting x values. Here x is -1, here x is -2, here x is -3, etc. When you list your domain and range, you always have to do domain from left to right. It's kind of like a number line. Your small numbers go to your left, your big numbers go to your right. So we would never list a positive to a negative. No. We would always list a negative to a positive. So order matters. If you get it backwards, I'm going to write you a little note that says, switch this, it's technically wrong. So touching the graph, touching the graph, touching the graph, touching the graph. Now, if I keep going this way, am I touching the graph? Well, not really. But remember we had this conversation about these arrows down here? They're going to keep going, and they're going to keep going. So my domain is actually at -infinity. It starts the whole way over there. Then we go the other direction. Touching the graph, touching. Would we be touching out here? Again, it doesn't look like it, but we actually would be, because this arrow is going to keep that graph opening ever so slightly. You know, it is a parabola. It keeps opening and getting bigger. though maybe slowly, but negative infinity to infinity. And actually, every single quadratic graph is going to have a domain of negative infinity to infinity every time. You don't even have to think about it. That is interval notation, or you could do inequality notation and say all real numbers. If you wanted to write the words all real numbers, that would work too. Go ahead and do it. Range, all the y values. So low to high. Now, I usually start here. And again, you have to go low to high. If you wrote a positive number to a negative number, that's technically wrong. You have to start with the low and then go the whole way to the top. Now, in this case, how low does this guy go? Like we're touching the graph, we're touching the graph. We're not touching the graph, but we have arrows. So I'm thinking negative infinity. So then the question is, well, how high does he go? This would be 0. This would be 1. This would be 2. This would be 3. This would be 4. Does it go to 5? No, it stops at 4. So this one goes the whole way to negative infinity up to 4. You can't touch infinity, but is this graph actually touching 4? Yes, it is. So we're going to put a bracket. Or if we wanted to use inequality notation, keep in mind range is a y value. Okay, so a y value, y is, and our y value is kind of here at this 4, and then he goes lower. So he's at 4, but he goes less than, so y is less than or equal to 4. That would be your inequality notation. Vertex. Vertex, I said, is kind of like the originating point, okay? And then what else did I say along with that? I'm going to go back. It's either a maximum or a minimum. So originating point, maximum, or a minimum. What I mean by that is right here. Do you notice how that's kind of the point, kind of right in the middle, and then part of the graph goes down here to the left and part of the graph goes down here to the right? So the vertex is just a point, and that point is specifically at -1, 4. So we would just write -1, 4. Now, as for a maximum or a minimum, I want you to think mountain or valley. Okay, is this red dot, is that vertex at the top of the parabola, or is it at the bottom of the parabola? So what I mean here is if your parabola was doing this and this was your vertex, this would be a minimum. Okay, it's at the bottom. It's at the lower part. Versus if your parabola does this and you're up here at the top, this is a maximum. Okay, it's on a mountain. It's at the maximum point. It's at the high. So if we take a look at this particular parabola, this vertex is a maximum. Now, axis of symmetry. Axis of symmetry is the line that cuts the parabola in half. So if you look at where your vertex is, we're going to come right here. We're going to go through the vertex, and we're going to cut the parabola in half. Notice how half of it is on the left, half of it is on the right. You also learn that symmetry is where you can like fold a piece of paper and it lands right on top of itself. If you fold this parabola over that green dotted line, it's going to land directly on top of itself. Now, the axis of symmetry is at -1, but more specifically, it is at x equals -1. That is a line. It is an equation to a line. You have to write it like that. Now, increasing and decreasing. This is where we really start to have some fun. And this is where if you printed these guided notes, you better be drawing all over them. If you didn't print them, you better be drawing a picture and drawing all over that. So we are going to trace our graph. When you trace a graph, it's like reading a book. You read from the left-hand side of the page to the right-hand side of the page. Well, when you read a graph, you do the same thing. So I'm going to start at the left side of my graph. I'm going to read my graph to the right side of my graph. So as I trace my graph from the left to the right, I'm going up and then I'm going down. Okay? So remember I said increasing is where the graph is going quote, quote, up, and decreasing is where it's going down. So up, increasing, down, decreasing. Now, for this one, most kids really like the inequality notation because the interval notation gets a little questionable. But I'm going to do both. Increasing is this part of the graph right here. I'm going up. Now, that you have to think of x values, okay? Not y values, x values. So over here on the left-hand side of my graph, if I were to follow this arrow would kind of take me out to negative infinity. So increasing, I start at negative infinity, up to, boom, that point right there at my vertex, or that line. And remember we said that that line that kind of cuts it in half is at -1. So -1. Now at this point we could either put a bracket or a parenthesis. I used to tell kids always put parentheses. Always. Because how can you be both increasing and decreasing at the same point? But then I went to a workshop for an AP calculus class, and my AP teacher said, no, you should put a bracket because that point does both. So for our purposes, I'm not going to judge you if you put a bracket or a parenthesis. If you put a parenthesis here at this -1, I'll give you credit. If you put a bracket there at that -1, I'll give you credit. I'm not going to mark you wrong either way because there's an argument on both sides of the fence. Okay, so increasing is this blue line that I have outlined a lot from negative infinity up to the -1, which means that is when my x value is less than or equal to -1. Meaning if I go grab my highlighter, here's your axis of symmetry. When x is less than the -1, meaning this side of the graph, that side of the graph is traveling up. Versus now if we're going to go do our decreasing, this side of the graph is traveling down. Well, that starts at the -1 and goes out to infinity. And again, bracket or parenthesis on this -1, up to you. I'm not going to mark it wrong either way. But on the infinity, you better have a parenthesis. That one's always a given. Or when x is greater than or equal to -1. So we're starting now kind of at that vertex, which is at the -1 x value, and we're going out to that way, which is positive infinity on the x-axis, not down on the y-axis, which is why I have positive infinity here, not negative infinity. Last but not least, we have to look at where our graph is positive and where our graph is negative. So positive, I said, was above the x-axis. So let me see if I can find my screen shade. There is my x-axis. So above that is where my graph is positive. So positive is from here to here. Just goes right there, from there to there. Now, do you know where this point is? I believe if I move my screen shade that point is at -3. Above the x-axis to +1. So from -3 to +1, I'm positive. Now again, same conversation. You wanna use brackets here? Use brackets. You wanna use parentheses here? Use parentheses. I'm not gonna mark it wrong. Or we could say that x is in between -3 and +1. And the way you read this, you start with x in the middle. X is greater than or equal to -3, meaning greater than, he's going that way. Or x is less than or equal to 1, meaning he's going that way, which kind of like sticks him in between those two numbers. This one's interval notation, that one's inequality notation. Last but not least, we're going to look at negative. Negative means below the x-axis. So below the x-axis, we kind of now have two sections. Okay, now I'm going to start with interval notation first. This first section over here on the left, where I'm below the x-axis, starts from -infinity. Then it comes up to this point right there on the x-axis, which is at -3. Parenthesis, bracket or parenthesis, I don't care. Then you notice that it kind of takes a break here. Like I'm following my graph, I get up to -3, but then instead of being negative, we jump into the positive. I don't want that. So we take a break, 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 and then we pick up again here at the 1. Then at the 1, I start being negative again, and I go down below the x-axis and the whole way out to positive infinity because the rest of the graph is going to be negative. Again, doesn't matter. That better be a parenthesis. And then in order to say, oh, but it's negative in both of these, you put a little u, which is a union. And there's 2 sections. Or. Now, do you notice up here when we did positive in my green pen that this had from -3 to 1 and it was in one set of brackets? So then when I wrote it in inequality notation, the x was in the middle and it had like one group of numbers. It was just all kind of put together. But if you go down here in the red, you notice that there's like 2 sets of brackets and parentheses. So this time when we write inequality notation, there's going to be 2 different x's in 2 different sets. So what I mean by that is the first part of your negative is over here on the left where it's -3 out to negative infinity. So that's going to be x is less than or equal to -3. Or x is greater than and equal to +1. So this would be your inequality notation versus this over here would be your interval notation. So there's like kind of like 2 different statements, one statement for the left, one statement for the right, versus up here it's all together because of the middle.